Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. This is our day 3 where we will solve a problem based on binary search. The level of this question is going to be medium and the name of the question is search in rotated sorted array. The link of this question will be in the description box and you can download this Excel sheet as well. The link of this Excel sheet is also given in description. Now without wasting much time, let's see our question. So this is our question and let's see what our question is saying. So it says that there is an integer array nums sorted in ascending order with distinct values. So basically we have given an integer array named as nums and it is sorted in ascending order, and very importantly question says that it only have distinct values. Okay, now prior to being passed to your function, nums is possibly rotated at an unknown pivot index k, right? And the value of k can be greater than equal to 1 or it will be lesser than nums.length, such that the resulting array is nums of k plus 1, nums of like up to nums of n minus 1, nums of 0, nums of 1 and up to nums of k minus 1, 0 index, right? So by reading this question for the first time, you may feel that it is very difficult, but trust me, it is going to be very easy. I'll explain you all the things, so please have some patience. So for example, it is given that we have an array 0, 1, 2, 3, 4, 5, 6 and 7 which is a sorted array, right? Which is a sorted array. So it might be rotated at a pivot index 3 and become 4, 5, 6, 7, 0, 1 and 2. Okay, we'll see what is this pivot index and how the array is rotated. Now given the array nums, after the possible rotation and an integer target, right, return the index of the target if it is in nums or -1 if it is not, right? So basically question says that you have given an sorted array which is rotated at any possible index, right, at any possible index, and you have to find, you are also given an integer target. You basically have to find this target is present in your nums array or not, right? And you must write an algorithm which with big O of log n runtime complexity. So basically they are saying that we have to write an algorithm which runs in big O of log n complexity, right? And here we have given some sample test cases. So let's analyze one of the sample test case. Okay, so this is one of the sample test case which was given on the LeetCode question. So firstly, let me explain you what is the meaning of rotated sorted array. Okay, so firstly, this array is not sorted, right? This array is not sorted, right? This array is not sorted. But what if this array would have been sorted? Then it would look like 0, 1, 2, 4, 5, 6 and 7, correct? Now I think you will agree with me that this array is sorted, right? And these are the indexes. Okay, now what if I take this 7 and I put it at index number 0, correct? Then this 7 will come at the index number 0 and all the remaining elements will be right shifted by 1, right? All the remaining elements will be right shifted. Okay, then how our array will look? It will look like 0, 1, 2, 4, 5 and 6, correct? Now again if I say just take this 6 and put it at index number 0, right? Then how our array will look? So we'll have 6 here and all the remaining, right? These are all the remaining elements. All the remaining elements will be right shifted by 1, right? Then 7 will come at this position, 0 will come at this position, 1 will come at this position, 2 will come at this position, 4 will come at this position and 5 will come at this particular position. Now again if I say just take this 5 and put it at index number 0, we just put 5 at index number 0. Now all the remaining elements will be right shifted, right? Will be right shifted. Now this 6 will come at this position, 7 will come at this position, 0 will come at this position, 1 will come at this position, 2 will come at this position and 4 will come at this position, correct? Now again if I say just take this 4 and put it at index number 0, we put this. Now all the remaining elements will again get shifted, right? All the elements will get right shifted by 1. So this 5 will come at this position, this 6 will come at this position, 7 will come here, 0 will come here, 1 will come here, and 2 will come here. Correct? And now our array, right? Now our array will look something like this. Something like this. So what we have done, right? What we have done. So we have given one sorted array, right? We had started with a sorted array. Then what we had done, we just took the last element, right? We took the last element and we put it the last element on the index number 0, and then we shifted all the remaining elements to right by 1, right? To right by 1. And now if you compare, this is something which is given into our question, right? This array 4, 5, 6, 7, 0, 1, 2 and this particular array 4, 5, 6, 7, 0, 1, 2, they both are same, and we have rotated this array, right? And this particular array will be called as rotated sorted array, right? Rotated sorted array, because we have rotated this array. Like how many times we have rotated? Firstly, we put 7 at the index number 0, so we rotated by 1, right? Then we put 6 at index number 0, that means that we rotated it by 2. Then we put 5 at index number 0, that means we rotated it by 3, third time. And then we put 4 at the index number 0, that means that we again rotated it. So overall, we have rotated this array 4 times, right? We have rotated this array 4 times. So what does the meaning of rotation, right? What does the meaning of rotation? Rotation simply means that take the last element and put it into front, or you can say 0th index, right? You can say that this is 0th index. Now the number of rotations, right? The number of rotations is nothing but k, which were mentioned in the question. So the number of rotation is nothing but k, and this k was mentioned in the question. Prior to given passed to your function, num is possibly rotated at an unknown pivot index k. So this pivot index k is nothing but it is how many times we have rotated the array, right? So basically we have rotated the array 4 times. Why we have rotated the array 4 times? Because these 4 elements, we put it these 4 elements from end to the starting index, right? Initially if you see that, then this 4, 5, 6 and 7 were at the end, and one by one we shifted these elements at the front of the array. So now I hope this particular thing is clear, what is the meaning of rotated sorted array. And now we will think of how we will solve this question, right? So 4, 5, 6, 7, 0, 1, 2, this is the test case. 4, 5, 6, 7, 0, 1 and 2, correct? Okay, and the indexes are 0, 1, 2, 3, 4, 5 and 6, and we will also be having a target variable. Let's say the target variable is equal to 0. So what we have to do, we just have to search this 0, right? We have to search this 0 in this array, and we have to return the index, right? We have to return the index. So from your eyes you can clearly see that this 0 is present in the array at index number 4, so we can return the index number 4. Now let's think about the intuition. How we will solve this question. So the very first approach which comes in my mind when I see this question is linear search, right? Linear search. I can directly do a linear search, and then if this particular element, if this particular target is present into my array, then I'll return the index, and if it is not present, then I'll return -1, right? So how the code will look like, let's see. So yeah, so let's say we have an answer integer which is initially -1. Why -1? Because question clearly says that if the target is not present, right? If the target is not present in array, then we have to return -1, right? For that reason. Now we will simply do a linear search. I hope most of you know what is linear search. We will write 0 for int I is equal to 0, I is lesser than n, and then I plus plus. What is this n? This n is the size of the array, right? This n is the size of the array. Then we will just check if the target is equal to ARR of I, right? Then what we will do, we will directly, right, we can directly return, or let's say we'll say that answer is equal to I, and then we will break this loop. So this is the only code which we have to do, and at the end what I can do, I can directly return my answer variable. So this is the brute force code. This is the code for the linear search, and I think you can probably guess the time complexity. We are basically running a loop from 0 to n, where n is the size of the array. So we can say that we are having a time complexity of O of n, and the space complexity is constant, right? That space complexity is constant, O of 1. So I hope that this approach is clear, but still let me just do a quick dry run to explain you how this work, right? So firstly, we have an answer variable which holds the initial value as -1, correct? Then our I is starting from 0, so I will come here and we'll see, is this 4 is equal to my target? What is the value of my target? The value of my target is 0. Is it equal to 0? You will say no, it is not equal to 0. Okay, then I will move at index number 1, right? Again we will check what is the value present at index number 1. It is 5. We will compare, is my 5 is equal to 0? You will say no, it is not. Then we will again move our I to the next index. Now the element present at index number 2 is 6, correct? We will again check, is my 6 is equal to 0? You will say no. Okay, don't do anything, just move at index number 3. Now here at index number 3 we have 7. We will again compare, is this 7 is equal to my target? The value of my target is 0. So is my 7 is equal to 0? You will say no, we will not do anything, right? We will not do anything. Then we'll come at index number 4. What is the value present at index number 4? It is 0. So we'll write 0 and we'll compare it with the target. The value of my target is 0 as well. We will check, is this 0 is equal to 0? You will say yes. Then what we'll do, in the answer variable we will store the index. What is the index? Index is 4, and then we will break out of the loop, and finally we will return 4, right? Finally we will return 4, which is our answer, right? So this approach is clear into your head, I guess, and the time complexity for this particular approach is O of n. But in the question it was clearly mentioned that we have to make an algorithm which runs at the time complexity of O of log n. So clear, it is very obvious that if we write this particular algorithm or this particular solution on LeetCode, we will get TLE. So now let's think of something, let's think of an optimized approach, right? Okay, so the test case was 4, 5, 6, 7, 0, 1, 2, right? This was our array, and let me write the indexes. Indexes are 0, 1, 2, 3, 4, 5 and 6. Okay, so firstly, one thing I want to say that in the question it was mentioned that we have to design, or we have to make an algorithm which runs at the time complexity of log of n, right? Where what is n? N is the size. N is the size of the array. So whenever you hear this time complexity log n and your input array is sorted, so whenever you see these two things, right, sorted plus log n of time complexity, then which algorithm comes into your mind? Which algorithm comes into your head? Binary search. Yes, you guessed it right, binary search. Because why binary search? Because binary search is a searching algorithm which works on the sorted array, right? And the time complexity of the binary search is O of log n, right? So from these hints we will come to a conclusion that we have to use binary search in order to solve this problem in a time complexity of big O of log n. Okay, so now let's solve this question. Before that, let me rub all this thing. Okay, so we have to use binary search and we are clear about this. Okay, so now how binary search starts, right? How binary search works. So we have a pointer, or we have a variable known as start, right, which is pointing to the 0th index initially, and then we will have another variable or pointer which will end to the last index. What is the last index of this array? 6, right? So it will point at 6. And we have another variable which is mid. What is mid? Mid is basically the middle index, or you can say the average of both the things start plus end. So we can either write start plus end divide by 2, or we can also write start plus end minus start divide by 2, right? So we will use this particular formula, right? The answer of both the things, the answer of both the formula will be same, but the reason why we use this formula is to avoid overflow, right? To avoid overflow, right? To avoid overflow, we basically use this formula, but the answer of both the formula will be same, right? For example, let's say we have start as 0 and we have end as 6, divide by 2, we get 3, right? And if I solve this with this particular formula, then at the start I will have 0, and end minus start, that is 6 minus 0 divide by 2. So 6 minus 0 is equal to 6. 6 divided by 2 is equal to 3. So 0 plus 3 is equal to 3, right? So finally you can see that this 3 and this particular 3, they both are same. Okay, so during the dry run we will use this formula, but in the code we will use this particular formula. Why? To avoid the overflow scenario. Okay, so I hope this is also clear. Now let me just rub it off and let's start a dry run, right? So with the dry run we will develop our intuition, right? We will develop our intuition with the dry run. Okay, so initially the value of mid will be 3, right? So this is where my mid is right now, right? So my mid is at index number 3, correct? Okay, now at every index, what I'll check? I'll check that if the ARR of mid, right, is equal to my target. If it is equal to my target, I will return, right? I will return what? I will return the index, right? I will return the index. So I'll check, is this 7 is equal to 0, because the value of my target is equal to 0, right? So is it equal to 0? So you will say no, right? You will say no. Now at this particular moment we have two options, right? Here we are mid, we have two options. Here we have start and here we have end. We have two options, right? What are the two options? Either I can go in this particular part of the array and I can discard this, correct? Or the second option is I can discard this portion of the array and I'll continue my search in this particular portion, right? So we have these two options right now, but how we will decide what to do? Either to go into the left side or to go into the right side of the array. How we will think of? Okay, so let's think again. One thing which we basically know, that binary search only works in sorted array, right? Binary search only works in sorted array, correct? So now we will try to go that part. We will try to go in that part of the array which is sorted, right? Which is sorted. We will go in that part of the array which is sorted. And how we will do that? It is very simple, right? So let's say we have a start variable here and we have an end variable pointing here, right? We will basically check that is this part is sorted. We will check, is this part is sorted? If this part is sorted, then what I'll do, I'll discard this portion and I'll continue my search here, right? Okay, so let's just try to do. Okay, so how I'll check that this part is sorted or not? Very simple. We'll just write ARR of start, right? if it is lesser than or equal to my ARR of mid, right? If this is the scenario, that means this particular part is sorted, correct? So what is the value at the index start? It is 4, and the value at index mid is 7. Is 7 is lesser than or equal to, so is 4 is lesser than equal to 7? You will say yes. What does it signifies? It signifies that, let me just change the color. It signifies that this particular part of the array, is sorted. It says that this particular part of the array is sorted. Now, if this particular part of the array is sorted, right? If this particular part of the array is sorted, it means that I can apply binary search here, right? I can apply my binary search here. Okay. Now, let's say what will happen if I discard this, and if I try to do a search only on this particular part of the array. So from your naked eyes, you can directly see that if we discard this particular array, right? If we discard this particular portion of the array, then our target which was present in this part, we will lost it, right? We will lost it. So from this, we came to a conclusion that we cannot directly jump over to a portion of the array which is sorted, right? So let's just write this. What's the point? We cannot directly jump to sorted portion of array, right? We cannot directly jump into sorted portion, because if we directly jump into the sorted portion, there is a possibility that our target may lie in the another portion of the array, right? So now what we will do, like let's see. Okay, so one thing which I know for sure, that this particular part of the array is sorted, right? This particular part of the array is sorted. Okay, so let me just write it. 4, 5, 6, 7, right? So 4, 5, 6, 7. Here I have my mid, and here I have my start. So for sure I know that this path is sorted. Now just tell me one thing. Can I check my target lies in this portion or not? Can we check that our target lies in this portion or not? The answer is yes. By using the property of sorted, right? By using the property of sort, we can very easily find out that my target is present in this particular portion or not. Okay, what is the value of my target? Value of target is my 0, right? So if 0 would have exist in this particular portion, then what I can say, that this particular target has to be greater than or equal to the element present at the least index, at the starting index, which is 4, and the target should be lesser than or equal to the element present at the last index, that is 7. But this is not the case. Okay, so let's say that for a scenario, let's say that our target is equal to 5. Now can we check that 5 lies in this particular array or not, right? This particular array or not? Yes, we can. How? So just see that the value of my target has to be greater than or equal to the ARR of start, correct? The starting index of the array, correct? And let me just rub it off. And the value of my target has to be lesser than or equal to ARR of mid. Now what is this mid? Mid is the last index of the sorted array. So what is the value of our target? Value of target is 4. What is the value of our ARR of start? It is 4. So is my 5 is greater than equal to 4? You will say yes. Okay, but value of target is 5. Is it lesser than equal to ARR of mid? What is the ARR of mid? ARR of mid is 7. Is 5 is lesser than or equal to 7? You will say yes. What does it mean? It means that the value 5, the value of my target 5 lies into this array, right? Lies in this array. So I hope this particular thing is clear into your head, that if we are trying to find an element which is present in my sorted array, we can just directly use this formula, right? We can directly use this formula. Let's take another example. let's say that the value of my target is equal to 4, right? Let's say my value of my target is equal to 4, and let's apply the same formula and let's see that we are getting our answer or not. So the target is 4. Now, is my target is greater than equal to ARR of start? Value present at ARR of start is what? Value present at ARR of start is what? It is 4. It is 4, right? So is 4 is greater than or equal to 4? You will say yes. Yes. Okay. Now we'll come here. What is the value of target? 4. Is it lesser than or equal to ARR of mid? ARR of mid is 7. Is it lesser than equal to 7? You will say yes. Again, it means that thus this target 4 is lies into my array, right? So this is the second thing which we have to keep into our mind. So what we have to do, we cannot directly jump to a sorted portion of the array. We cannot directly jump into the sorted portion of the array. Instead, we have to check, right? We have to check that our target exists in the sorted array or not, right? We have to check this. So these are the 2 points which are very important. So these 2 points are very important, right? Firstly, we have to check that our which part of the array is sorted, right? Which part of the array is sorted? Is it the left part or is it the right part, right? Now once we know that which part is sorted, then we have to check, then we also have to check that our target lies in the sorted array or not, right? So these are 2 points which are very important, and if we are clear with these 2 points, then we can very easily solve this problem, right? So let me just write the test case again at the end. So we have 4, 5, 6, 7, 0, 1 and 2, correct? And the indexes are 0, 1, 2, 3, 4, 5 and 6. So initially my end is here, my start is here, and my mid is here. I will check, is this 7 is equal to my target? No, it is not. No, it is not. Okay, so I will check, is left part is sorted? Is the left part is sorted? You will say yes, yes it is sorted. Again I'll check, in the left part, does my target is 0. I'll check, does my target exist in the left part? You will say no. You will say no. Then what we will do? We will discard this portion. Why we will discard the portion? Because we know that our target does not lie, right? Our target does not lie in that portion, right? Our target does not lie in that particular portion. If it does not lie in that particular portion, we do not have to use this particular part, right? This particular part of the array is useless for us, right? Okay, then what we will do? Then what we will do is the next question. Okay, then so here was our mid. We will say start is equal to mid plus 1, right? So now my start will come here, my end is here. Again we will calculate the mid. So the value of end is 4, the value of start, sorry, so the value of start is 4, the value of end is 6. I'll do 4 plus 6 divide by 2, it will give me 5. So the value of mid will be 5. Okay, so here now my mid is, right? Here now my mid is. So now I will again check, is the left part is sorted or is the right part is sorted, right? Is the left part is sorted or the right part of the sorted? Right part is sorted. So we will see that this left part is also sorted, right? The left part is also sorted. It has 0 and 1, correct? And the right part is also sorted. The right part is also sorted. Okay. Then we will apply the second condition. We will check that is my target is present in the left portion, is my target is present in this particular array or not. Now we'll just check that is this my target is present in left portion or not. So for that we will use the formula, that is target is greater than equal to ARR of start and my target has to be lesser than equal to ARR of mid, right? ARR of mid. Okay, so what is the value of target? 0. What is the element present at the index S, at the index start? It is 0. Okay, I'll write 0. Is 0 is greater than or equal to 0? You will say yes it is. And again the value of target is 0 and ARR of mid, right? ARR of mid, what is the value present at the index M? That is 1. So 1. So I'll check, is this 0 is lesser than or equal to 1? You will say yes. What does it mean? It means that my target lies in the left portion of the array, right? My target lies in the left portion of the array, right? So now what I'll do, what I will do, I will just discard the right portion, right? I will just discard this portion and I will commit this portion, right? So now my end will be mid minus 1. So now here is my mid, right? My mid will come at this point, right? My mid will come at this point, and the remaining array will be this, right? Again, I will check that if the element present, at index mid, is it my target. I will again just check, like, if ARR of mid is equal to my target. If it is, then I'll return the index. So ARR of mid is what? 0. Is it equal to my target? What is the value of target? 0. Yes. Then just return the index. What is the index? Index is 4, and this is our answer. So in this particular way, we can solve this question. So let me just explain you this with the same example, but with a different value of target, right? Okay. So let's say we have something 4, 5, 6, 7, 0, 1 and 2, right? And the indexes are, we have 0, 1, 2, 3, 4, 5 and 6. Okay, let me just change the color. Yeah, and here is our end. Here is our end variable. Here is our start variable, and we calculate the mid. So mid will be start plus end divided by 2. That is 0 plus 6 divided by 2. We'll get 6 divided by 2, which is equal to 3. So now my mid will come at this particular position. Okay, now let's say that my target, is 1, right? Let's say that my target is 1. I'll check, okay, is this 7 equal to my target? You will say no. Okay, then I'll check, I will check that is the left part is sorted. So you will say 4, 5, 6, 7. Yes sir, it is sorted. Okay, then I'll check, is my target exist in this particular sorted array? You will say no sir, 1 does not exist in this sorted array, right? We will use that formula for it, right? So what we will do, we will basically discard this portion, and we will do start is equal to mid plus 1. So now my start will come at this position, right? My start will come at this particular position. Okay, now I will again calculate my mid. So what is the value of mid? Start plus end divided by 2. So the start variable is now holding the value 4 and the end variable holding the value 6. So 4 plus 6, 10 divided by 2 is equal to 5. So right now my mid is this particular position. Now I'll check the value present at this index. Is it equal to my target? So see, my target is it equal to ARR of mid? So you will say yes, because the value present at the mid index is 1 and the value of our target is also 1. So they both are same. So what we will do, we will just return the index. What is the index? Index is 5. So we'll just return this 5. Okay. So I hope the intuition is clear into your head. If you have any doubt, you can do a dry run on the different examples. So now, without wasting much time, let's write the code. So what we will need a start variable which will point at 0, and then we will need an end variable which will point at the last index. So what is n? N is basically the size of our array, correct? Then what we have to do, we have to run a loop, because this is a very simple or traditional kind of binary search problem. So here we'll write until and unless my start is lesser than equal to end. Just run the loop. Every time we come, we calculate the mid. So mid will be start plus end minus start divided by 2. We will check that if the target is equal to ARR of mid, is my target is equal to ARR of mid, then what we will do, we will simply return the index that is going to be mid. Okay, if it is not, then what we have to check? We have to check left portion is sorted or not. How we will do this? Very simple. We write if ARR of start is lesser than equal to ARR of mid. What does this signifies? it signifies that the left portion is sorted. Okay, so now we know that the left portion of the array is sorted. What is the second task? What is the second task? Check. Again we have to check that my target lies in this portion or not, right? This portion or not. So how we'll do this? It's very simple formula. We'll say my target, it has to be greater than or equal to ARR of my start, and my target, it also has to be lesser than or equal to ARR of my end, right? If this is the condition, that means that in that particular sorted array our answer lies. Then what we will do? We will do end is equal to mid minus 1. We will go in that particular part, right? We will go in that particular portion. If it is not, then what? We will go the other portion, will write start is equal to mid plus 1, right? Instead of end, it is start. Okay, yeah. So this is the one condition where we have checked two things. What's the first thing? First, that is particular left portion is sorted or not. Then we check that my target is lies in that particular part of the array, in that particular left portion of the array or not. If this is the case, like if this particular left portion is sorted and my target also lies in this particular portion, then what I'll do, I'll discard the right portion and I'll come to this left portion. Therefore I have written this line end is equal to mid minus 1, right? Now think about the second situation. This left part is sorted but my answer does not lie in this particular part. Then what I'll do, I'll discard this and I'll go to this right portion. Therefore I have written start is equal to mid plus 1. So I hope this particular part is clear into your head, right? Now we are running a if condition. We are just checking that if left part is sorted or not. So let's say we have this sorted rotated array, right? Rotated sorted array. Here we have the left portion and here we have the right portion. Now think of yourself, think it by yourself that if this left part is not sorted, then this right part will definitely be sorted. This is one of you can say one of the properties of the sorted rotated arrays, that if one part is not sorted, then the other part will definitely be sorted, right? Then the other part will definitely be sorted. So let me just take this particular example, right? We have 4, 5, 6, 7, 0, 1 and 2, right? Now let's say that let's say here is our end, here is our end, and here is our start, correct? Now we'll check, is this particular portion is sorted? You will say no, this portion is not sorted. If this portion is not sorted, then the remaining portion will always be sorted, right? Because this is a property, of sorted rotated arrays. Because if one part of the array, if the left portion is not sorted, then the right portion will be sorted, or if the right portion is not sorted, then left portion will always be sorted, right? So from this we can see that if this part is not sorted, then this particular part will always be sorted, right? So this is the case here. Let me just zoom. Okay, so from this particular part we came to know that this is the condition if my left part is sorted. Now let's say if my left part is not sorted, then what I'll do, I'll go to my right part, right? But can I directly go to my right part? The reason is no. I have to again check that if my target lies in this portion or not, right? Target lies in this portion or not. We have to check this. How we will check? Very simple. We'll write that this my target has to be greater than or equal to my ARR of mid, correct? And the target has to be lesser than or equal to ARR of end, right? If this is the case, then I'll go into that portion. Then I'll write start is equal to mid plus 1, correct? And if this is false, then I'll go back to the left portion, which is end is equal to mid minus 1. Okay, so this is the code. It might looks clumsy, right now, but I hope the intuition is clear into your brain, right? The intuition is clear into your head. We are just checking two things: which part of the array is sorted, right? Which part of the array is sorted, and if that particular portion is sorted, then we are checking that my element, my target lies in that portion or not. If yes, then I'll go to that portion. If not, then I'll go to the other portion, right? So I hope this is clear. Let me just code it, and by coding, right, by coding it will be more clear, right? It will be more clearer to you. Okay, so what we'll do, we will have a start variable which will point to 0. Then let's say int n is equal to nums dot size, and we'll have int end is, it will be equal to n minus 1, right? Let me just adjust it. Okay, then we just have to run a while loop, but before that we also need our answer variable. So the answer variable is -1 initially, correct? And we will also return our answer. Then we'll write if start is lesser than or equal to my end. Every point I'll calculate mid, so mid is equal to start plus end minus start divide by 2, right? Now what we have to do, we have to just check if the nums of mid, is it equal to my target. The value of the, like, the spelling of the target is wrong, so target, target. If this is the case, then I will simply return my mid at that particular moment itself, right? Now what we have to check, we have to just check left part is sorted or not. Okay, how we will check? We will check that in this way. So the nums of start has to be lesser than or equal to nums of mid, right? If this is the case, then it means that the left part is sorted. If the left part is sorted, we have to check that my target lies in sorted portion or not. How we will check this? We'll write very simple, target has to be greater than equal to nums of start, and my target has to be lesser than or equal to nums of end, right? If this is the case, then we will go in that particular portion, right? So here both the conditions are satisfied. So what we will do, we will write end is equal to mid minus 1, right? We'll go to the left part. If this is not the scenario, then what we have to go, we have to go to the right part. So we'll write start is equal to mid plus 1, right? So now if this left part is not sorted, then what we have to do, we have to check the right part, right? Again we will check my target lies in that particular portion or not. So we'll write my target has to be greater than equal to nums of mid, and my target has to be lesser than or equal to my nums of end, nums of e, right? If this is the case, then I'll do write start is equal to mid plus 1. Else what we will do, we will go to the left portion. So we will write end is equal to mid minus 1. Okay, so this is the code. I hope this is clear. So we have a start variable pointing to 0. We have n, which holds the size of the nums array. Then we have an end variable e, which is pointing at the last index. Then we have answer, which is initially -1. So we'll just calculate the mid every time we come into this loop. Then we check that if the element present at the mid index is equal to my target or not. If this is the scenario, I'll return the mid index. If this is not, I'll check the left portion is sorted or not. If the left portion is sorted, then I will check that my target lies in the left portion or not. If it lies in the left portion, then I'll go to the left part of the array, and if it is not the case, then I'll go to right part of the array, right? Else what I'll do, else if the left part is not sorted, this means that the right part will definitely be sorted. So again in the right part, I'll check that if my target lies in the right portion or not. If yes, then I'll go to the right part. If no, that I'll go to the left part, right? And at the end we are returning our answer variable. So suppose in any case, if my target is not present in my array, right, then this line will never get executed, and from here we will return the answer. What was the initial value of answer? Initial value of answer was -1, so -1 will be returned, right? -1 will be returned if the element is not present. So let me just run this and see it is running fine or not. Okay, so here we can see that all the 3 sample test cases are passed. Now I will just submit this. Okay, so let's see. Okay, so here for one test case we are getting a wrong answer. So it is 1 3, the target is 3, and we are getting -1 as an output. Okay, so let me just see. Instead of E we will have mid here. Okay, let me just take this, let me just use this test case and let me run it again. Yeah, so now you can see that the last test case which was wrong here is also running fine. So there was a small issue in our code, so I had written it wrong. So the target has to be greater than equal to nums of start, nums of s, and the target has to be lesser than equal to nums of mid, right? Similarly, target has to be greater than equal to nums of mid, and the target has to be lesser than equal to nums of end. Now if I submit this, I hope now it should run fine. Okay, so here you can see that this particular solution is accepted. So this was all for this particular video. For this particular solution, we had applied binary search, and the time complexity for this is big O of log n, because the time complexity of a traditional binary search is log of n. And I hope you enjoyed this video. Comment down if you have any different particular approach, and comment down your experience while solving this particular solution. And if you have liked this video, if this video was useful, helpful for you, please like this video and do a comment and subscribe this channel as well. We will meet tomorrow with the next question.